welcome you all in this presentation related with the subject fundamentals of surface engineering. And so far we have talked about the various mechanisms which lead to the loss of material from the functional surfaces. We have also talked about the important surface properties and the materials which are available for surface modification, so that the surface properties can be modified according to the requirements. So, under the surface modification techniques, we have seen that there were three categories of the surface modification. One wherein just the change in surface metallurgy is used to modify the surface characteristics, and in this process only the metallurgical changes are brought in. Then we have also seen another category of the processes where the change in the surface properties is brought in through the chemical composition modification of the surface and near surface layers. So, what we have seen that whatever the elements we want to introduce at the surface and near surface layers, the suitable environment enriched with that particular element is created, and so through the chemical interactions, through the diffusion and through the fusion, these alloying elements or these elements get mixed with the surface of the substrate. In this category, what we have seen that we have talked about the two processes. These were the like carburizing and the nitriding. Apart from these two processes, wherein carbon and nitrogen is introduced at the surface, we have also seen like carbonitriding, in which carbon and nitrogen both are introduced, followed by the post surface modification heat treatment. And in case of cyaniding, primarily nitrogen is introduced along with the carbon to improve the surface properties. In both and in all these four processes, we have seen that the carbon and nitrogen concentration at the near surface layer is introduced, and which in turn helps in improving the properties after the heat treatment. Heat treatment primarily here is used to have the metallurgical transformations like austenite to martensitic transformations, so that the hardness can be enhanced. While in case of the nitriding, no post surface modification heat treatment is needed, and this process directly forms the kind of nitrides which are required at the surface for improving the hardness, wear resistance, and introducing the surface compressive residual stresses, which in turn helps in improving the tensile properties as well as the fatigue resistance. What we have seen basically in the processes like carburizing and the nitriding, both these kind of the processes, carburizing and carbonitriding and cyaniding, these processes are carried out at quite high temperature, like 900, about 900 degrees centigrade. This temperature may vary from 850 to 950 degrees centigrade. While the nitriding is carried out at a low temperature, like say 550 to 600 degrees centigrade. These processes are slow and they take long time. These processes are slow and therefore they take long time to modify the surface composition by introducing the carbon or the nitrogen at the near surface layers. And this is the another negative side. So there are two negative sides related with these processes: the high temperature, which tends to modify the surface structure of the bulk material also, and that can be undesirable for the mechanical properties of the main component itself. And another undesirable aspect apart from the high temperature exposure is the long time requirement. So the process is slow. So these reduce the high temperature adversely affects the mechanical performance, while the long time adversely affects the productivity, which in turn reduces the increases the cost of the product and reduces the productivity. And considering both these aspects, like high temperature as well as the longer time, the further improvement in these processes have taken place in form of like plasma nitriding and plasma carburizing. So if we see both these processes, the basic principle in both these processes is same, wherein like in carburizing, carbon content at the surface layer is increased, while in case of the plasma nitriding, nitrogen content at the surface layer is increased. This is used for formation of the nitrides as in case of the simple nitriding, and this is used for forming the high carbon martensite after the suitable heat treatment. But the only difference is here is that that we use the plasma for making the carbon and nitrogen available for diffusion and subsequently surface modification. So this is the only difference in this process. In conventional processes, what we have seen, conventionally what we do, we use the suitable gas mixture or chemical in form of the molten bath, or we use the solid powder particles, and lot of the thermal decompositions are involved for making these required constituents into the carbon and nitrogen available for diffusion. So lot of the thermal decompositions and chemical reactions at a high temperature take place for making the carbon and nitrogen available for the carburizing and nitriding respectively, and these in turn make the process slow and needs to be performed at a high temperature. High temperature is needed so that that we can get the sufficiently high diffusion rate in order to achieve the required depth of the modified surfaces for surface property enhancement. As compared to our conventional carburizing and nitriding process, where a lot of thermal decompositions and chemical reactions take place for making the carbon and nitrogen available at the surface so that these can be introduced at the surface. In case of the plasma carburizing and nitriding, basically using the suitable conditions for the plasma generation of suitable gas is used. So like if you want to do the plasma carburizing, then suitable the gas mixture containing the hydrocarbons like methane or CH3H8 or the hydrogen and the argon mixtures are used, so that the plasma of these gases is created around the component and making the active atomic carbon available in form of plasma. So this carbon is formed immediately and making the carbon available under the suitable conditions of pressure, temperature and vacuum. So the potential difference between the anode and cathode. So these are the conditions: pressure, temperature and potential difference. Once we are able to optimize the suitable conditions in presence of the required the gas mixture, then the plasma of that particular gas is produced, and that plasma will be making the required element like carbon or nitrogen available in the atomic form, and which will readily be available for diffusion into the surface of the component. So here, since the plasma of that particular gas is directly making the elements available for diffusion, and this makes the process fast, quick, and therefore plasma carburizing and plasma nitriding processes are comparatively faster than the conventional carburizing and conventional nitriding processes. So what we do basically in this process, basically we use one big chamber like this, and this chamber will be connected to the vacuum pump. So this will be creating the required low pressure. Then we have the another opening through which we can feed the suitable gas mixture. Like for plasma carburizing, it can be methane plus C3H8, propane plus hydrogen plus argon. Such kind of the gas mixture is used, or for plasma nitriding we may introduce the ammonia. Then we have one heating arrangement. This we can say as heater, which will raise the temperature sufficient to form the plasma, and around this we have one anvil or the support over which the job to be modified will be placed. So like say this is the workpiece which is to be modified. Now all these things will be enclosed in insulating chamber, and that will also be connected to the, that will also be made anode. So basically there is another you can say thermal insulator, and this is made anode. So we need to connect the we need to make one component as an anode and one component as a cathode to form the plasma, so that sufficient potential difference between the anode and cathode can be created. A workpiece is made cathode by connecting it to the negative terminal, and this thermal insulating chamber is connected to the positive terminal, so it is made cathode. And the sufficient, when we have the sufficient potential difference, between the anode and cathode in presence of the suitable gas mixture, whether it is ammonia or the other hydrocarbon gases, these form the plasma, making available carbon or the nitrogen available for diffusion to take place at the surface. Once the active carbon or nitrogen available in atomic state, these will be in the workpiece. Because of the concentration difference, these will start diffusing under the favorable conditions of the temperature. We need a very good combination of the temperature within the plasma chamber, and the temperature may vary in the range of 300 to 800 degrees centigrade. So as compared to the typical carburizing and cyaniding temperatures, this temperature is quite low. Because that is normally performed in the range of the temperature like say 850 and the higher values. And then the pressure which is created through the vacuum is also varies in the chamber, which can vary from 30 to 1000 pascals. And then these are the gas mixtures which are fed in. Under the optimum conditions of the pressure, which is maintained through the proper pressure is maintained through the vacuum pump. So we need to see that the pressure for a given gas mixture which will be used for forming the plasma, the pressure is optimized properly, because if the optimum pressure will be resulting in the plasma with the required conductivity and the availability of the plasma forming gas to which will be leading to the plasma of that particular gas mixture to make the carbon and nitrogen available. But if the pressure is high or pressure is low, in both the cases we don't get the required kind of the plasma formation process, and that can spoil the process as a whole. For example, the pressure actually affects the intergaseous particle spacing. So interparticle spacing in the chamber is affected by the pressure. So when the pressure is high, it will be leading to the close gap between these gaseous particles, and which in turn will be leading to the increase of electrical conductivity. So when the pressure is high, electrical conductivity will be high due to the closer gap between closer interparticle spacing, and higher electrical conductivity will have the tendency for increased tendency for arcing between the workpiece and the between anode and cathode. This is what we can simply say. And when the pressure is low, the interparticle spacing is wide, which will be leading to the higher lower electrical conductivity, and low electrical conductivity will disrupt the discharge or plasma formation process. And so it is neither it is good to have the higher pressure within the chamber, or nor it is good to have the low pressure within the chamber, because in either case it will be leading to the problem in terms of the arcing for high pressure and the disruption of the plasma formation due to the low under the low pressure conditions. So now if we see the typical plasma nitriding when it is carried out on the typical steel AISI 410 steel, when it is subjected to the plasma nitriding for surface modification up to the depth of 30 micrometer by forming the iron nitrides and nitrides of other elements present in the steel. This will be leading to the increase of hardness up to 1000 HV. So this significant increase in the hardness is achieved like the typical martensite offers the hardness of the 800 to 900 HV. So after the plasma nitriding, we get the sufficient depth and the hardness value which is much higher than what is typically achieved through the carburizing by the martensitic transformation. So 1000 HV hardness is achieved, and this will be achieved after the nitriding, plasma nitriding for 20 hours. So we get the significant depth and significant improvement in the hardness through the hardness through the plasma nitriding. And we know that when since these transformations take place through the increase of a specific volume, and therefore these will be leading to the development of the residual compressive stresses, and these residual compressive stresses will be increasing the tensile strength of the material. This will be increasing the fatigue resistance or fatigue strength of the material. At the same time, the increased hardness and the developed residual compressive stresses will be leading to the improved wear resistance. So it is always good to have the plasma nitriding for those applications where it is required to have very good combination of the improvement in tensile properties, fatigue resistance, and the wear resistance of the material. Now here there is an additional aspect related with this process. This is called like the plasma carburizing or plasma nitriding. In these processes, whenever we see that between the chamber and the workpiece, which is negative, acting as a cathode, and the chamber is acting as a anode, and we are placing the workpiece here. Through the heater we are generating the required heat for increasing the temperature of the workpiece. So, and the vacuum is created using the suitable vacuum system, and the suitable plasma forming gas like NH3 or CH4 or C3H8 is fed, and these will be making the carbon and nitrogen available for diffusion to take place. Whenever under the suitable conditions of pressure, temperature, and the potential difference between the workpiece and the chamber, which is means anode and cathode. Workpiece is cathode and chamber, enclosed chamber, is anode. Whenever this plasma is formed, plasma of that particular plasma forming gas is formed through the discharge process, we get the plasma which is glowing. So this the plasma glowing leads to the very typical feature of this kind of the process, and that is why it is called glow discharge process. And this glow discharge is typical indicative of the formation of the plasma during the plasma carburizing or the plasma nitriding. So far we have talked about environment of the suitable element is created around the surface of the component, which is whose properties are to be improved, and this may be in form of the solid particle like in pack carburizing, or this may be in form of the molten salt bath like in case of the liquid carburizing, cyaniding, and it may be in form of the gases like nitriding and the gas carburizing. But in those processes we have seen that a lot of thermal decompositions and the chemical reactions are involved to produce the carbon and nitrogen, which can be used to diffuse into the surface and the subsurface region of the component for realizing the surface modification. In case of the plasma carburizing and the nitriding, what we have seen that basically the plasma is produced using the suitable combination of the pressure and temperature, so that so that the required elements like carbon and nitrogen can be made available in the atomic state for the diffusion onto the surface of the component, so that required improvement in surface properties can be achieved. Now we will be talking about the another category of the surface modification process by changing the chemical composition, and which basically involves the use of vacuum. So those we can say this also involves the diffusion. So there are few categories of the processes where we need to use vacuum, and diffusion is used to modify surface properties, and for this purpose we may use the chemical reactions, we may use vapors, or we may use ions. These are the three category of the processes which are used. These are three you can say the mediums which are used to modify the surface composition in presence of the vacuum using the diffusion mechanism, so that the surface layers, surface and surface layer properties can be modified up to the required depth. However, this category of the processes will be leading to the development of very thin modified layer. However, these result in very significant improvement in properties. So those properties where we use vacuum and diffusion to modify the chemical composition by using the different mediums in form of chemical reactions, vapors and the ions, such kind of the processes are called the vacuum, diffusion based surface modification processes. So in coming lectures we will be talking about the few processes where vacuum and the diffusion is used to modify the surface compositions using the chemical reactions, vapors and the ions, so that the required properties, required improvement in surface properties can be realized. Now here I will summarize this presentation. In this presentation basically I have talked about the plasma carburizing and the plasma nitriding to make the carbon and nitrogen available for surface modification. Thank you for your attention.